Welcome to IBM Works e-learning modules. My name is Mette Sønderskov. I'm from Aarhus University, Department of Agroecology in Denmark. This video is part of Module 3, Integrate Weed Management, and it will present Chapter 1, Introduction to Integrated Weed Management. Reduced reliance on chemical herbicides is needed. There's a general concern from the society related to human health and the environment and protection of that. A major concern is the protection of our water resources, both the surface waters and groundwater. This is no different for herbicides and weed management compared to other pesticides and other chemicals. These are, as I said, of general concern for the society due to the unwanted impacts on human health and the environment. The protection of our drinking water resources, whether it is surface or groundwater, is another major concern. And at the same time, the protection of wildlife is highly important. The residues of pesticides in the produced food and feed are another major concern. In order to limit the reliance on pesticides, we need to create more robust cropping systems that builds on preventive measures rather than reactive control actions. The following chapters in the weed module will focus on strategies to build robust cropping systems with regard to weed management. Besides these concerns, we also experience reduced efficacies of a long list of herbicides, which we have been relying on for decades. There is an increasing number of resistant cases worldwide among weed species. The classification of herbicide active ingredient grouped the modes of action into 25 classes, which are named HRAC 1 to 25. HRAC is short for the Herbicides Resistance Action Group. Of these, there are only 8 classes where no resistant cases have been reported. The database I refer to here is often referred to as the Ian Heap database, named after the man who created it. It can be found at the weedscience.org site. On that site, you can find different ways of summarizing the reported resistant cases. The presented graphs are for 2021. The first graph shows the number of unique cases reported to the database, and it shows that this number is constantly increasing. The next graph, now on your right, show the 5 most common modes of action for which resistance is reported. The top one being the ALS inhibitors, that is, for example, the sulfonylureas. This is the red line. And the next one is group 5, which are the photosystem 2 inhibitors. That could be triazines. The group 9 is glyphosate, and group 1 is azaces, that is the FOPs and DIMPs. Group 4 is the plant hormone imitators like auxins. A slight decrease in the rate for ALS resistance cases seems to be evident in 2010, but we should be careful with the interpretation of this, because it is primarily researchers reporting to this database. And maybe the evidence of ALS resistance is so well documented now that less research is carried out for this mode of action, and this would lead to a lower number of cases being reported. For glyphosate, the increase in cases is fairly constant. So which weed species are actually resistant? The top 10 of plant families are lined up in this figure, and it is clear that the grass weeds constitute a very large part. This is the Poaceae family. But also the dicotyledonic family of Asteraceae is represented with a high number. This is the Compositae family with well-known species like chamomile, cornflower, and fleabane, Cornuaceae. So the annual weed species are clearly the most common among the resistant weed species, and this aligns well with their frequency in arable fields. So this was a very brief update on the resistance situation, and resistance is very often a driver for farmers turning to increased IPM implementation. But this reactive response to a problem, which has already become severe, is not the best strategy. So let us move to the concept of holistic IPM. In general, integrated pest management is the principle of combining many tactics to build a management strategy that relies on both preventive measures and direct control with as much non-chemical pesticide control as possible. Relying completely on chemical pesticides is a short-term reactive practice. And we want to move to a more long-term proactive practice. So the short-term management is primarily direct control, but you can use precision or band spraying and target the management to actual population of pests, which is the first step to diversify the short-term control strategy. But this certainly needs to be supplemented by increased monitoring, evaluation, and use of decision support systems. To move into a truly long-term management strategy, redesign of crop systems, of the crop rotation with focus on cover crops, fertilization strategies, soil tillage strategies, and establishment timing is essential. Beyond this, the agricultural landscape with hedgerows, field distribution, and biodiversity strips, for example, flower strips or grass strips, are steps towards a holistic IPM strategy that helps prevent the establishment of pests and proliferation of pests. This is true for all pests, not only weeds, but it is extremely important for weed management as weed populations develop over time in the fields, and the amount of weed seeds put into the soil seed bank every year will have an influence for many years to come. Therefore, the best IPM practice takes a wide range of tactics into account and is evaluated on the long-term efficacy, thus moving from a reactive strategy to a proactive strategy. This is what we in the IPM project call holistic IPM. So in the IPM Works project, the participating farmers of different countries have reported on the practices and their use of pesticides. From the information given by the farmers, an IPM index was built. This is ongoing work, and the index here is the first attempt to build the score system in the project. So to understand this graph, I just briefly want to tell you about the TFI. This is a treatment frequency index, which you see on the left on the y-axis. What we use here is a simple measure of the amount of pesticide used in the field. And for now, the important thing is that you know that a higher TFI means that a higher amount of pesticide is used. And for the IPM measures, the IPM index, the more IPM measures that a farmer report on using, the higher the IPM index. There are, however, a group of farmers who do not score high on the IPM index. You can see there's a bunch of farmers lying between 15 and 20, and they have a which is lower compared to the one scoring 30 to 35, of course. And you can see that they have actually a low treatment frequency index. And this means that they're actually using less herbicides, even though they do not score very high on their IPM index. We don't know the reason yet, not that far in the analysis, but it could mean that they could have the temporary grassland in the rotations. You can see the dark green dots are the farms with grassland, and there are some of them down there in that group. And in general, you have lower TFI when you have temporary grassland in your rotation because very little pesticides is used in that crop. It could also be that these farmers are actually just more tolerant to the pests they have in the fields. They allow a little more than the other farmers before they go spraying. And maybe this means that they use less prevention spraying. This is also sometimes referred to as program spraying, which is planned ahead, no matter what pest you see in the field. So when separating the TFI for herbicides, because the first graph here is on all pesticides, the tendency is less clear. But the trend is still there. When you have a high index, this is IBM index, IBM measures in weed management. Where this index is high, you have a lower TFI. So it underlines the importance of working with new ways of reducing herbicides, because it seems to be more difficult than reducing yield pesticides. So it underlines the importance of research and development of weed management strategies. So this was a very brief introduction to the weed module. So the main point is that we need more than simple optimization of efficacy and substitution of herbicides to achieve a reduced reliance on pesticides in general and also on herbicides. So in the next chapters, you will have more about the biological background to support integrated weed management, on the effect of season, the effect of weed seed survival and input to the soil seed bank, the essential biology of the weeds, and the competitive ability of weeds also. And moving from that chapter into the more technical tools and tactics to improve the strategy of weed management, we will present the IWM framework, which is a concept with 5 pillars, which are the diverse cropping system, the cultivar choice and establishment, the field and soil management, direct control, and monitoring and evaluation. And finally, in the weed module, you'll also find case studies, examples of integrated weed management tactics and strategies. And there are also some material which can support workshops, discussion among advisors in training modules. Thank you for your attention.